In our last lesson, we learned how to create variables using integer, float, and char. Variables are powerful because their values can change. But what if you have a value that you never want to change? Imagine you define pi as 3.14159, and then 500 lines later, you accidentally change its value. Your entire program's calculations would be wrong. In programming, we have a special way to protect these important values. We don't use variables. We use constants. Welcome to Lesson 2.03. Today, we're learning how to create variables that cannot be changed. A constant is a read-only variable. Once you give it a value, it is locked for the entire life of the program. This makes your code safer, you can't break it by accident, and more readable. There are two primary ways to create constants in C, and we will learn both. The modern way, the const keyword. The traditional way, the #define directive. First, why do we need constants? The magic number problem. Let's imagine you are writing code to calculate sales tax. You might write, final price equals original price times 1.07. What is 1.07? It's a magic number. If you see this code 6 months later, you might not remember what it is. And if the sales tax changes, you have to hunt through your entire program to find and replace every 1.07. A much better way is to use a constant. Const float sales tax equals 1.07. Final price equals original price times sales tax. Now, your code is readable, and if the tax rate changes, you only have to change it in one place. Second, method 1. The const keyword, modern and preferred. This is the best and most modern way to create a constant. The syntax is simple. Just add the keyword const right before the data type when you declare a variable. Now, this variable is read-only. What happens if you try to change it? The moment you try to compile this code, the compiler will stop you and give you an error. It's protecting your code for you. This is a true variable with a data type and a value, but the compiler just prevents you from modifying it. Third, method 2. The #define directive, traditional. This is the older classic C method. You will see this everywhere in older C code. #define is a preprocessor directive just like #include. It runs before the code is compiled. The syntax is different. Pay close attention. #define pi 3.14159. Notice, there is no data type, int, float, no equal sign, and no semicolon at the end. How does it work? #define is a simple text replacement tool. Before compiling, this compiling is a phase of the 4 phases of the compiling we know. The preprocessor goes through your file, finds every single instance of the word pi, and replaces it with the text 3.14159. Fourth, const versus #define, which one to use? Const is almost always better and safer. Const is a true variable. The compiler knows its data type, like int or float. #define is just text replacement. It has no understanding of data types, which can sometimes lead to very strange bugs. Rule of thumb: use const whenever you can. Use #define only if you have a specific reason or if you are working with older code. Now you know how to store data that changes, variables, and data that doesn't change, constants. We have all our building blocks. It's finally time to use them to perform calculations. We need to learn how to add, subtract, multiply, and divide these values. Click on the next video to start Lesson 2.04. Operators. Arithmetic operators, where we will learn how to use addition, subtraction, multiplication, division, and the modulus operator.